Hello class, in this lecture I will talk about confidence interval. So this is chapter 9.3 and 9.4. So usually confidence interval we kind of say 1 minus alpha percent confidence interval. So when I am saying 90% confidence interval, 1 minus alpha is 90%. So when we have 90% confidence interval and we wanted to determine what is alpha, by the way, alpha is also called is significance level. So when I say 95%, 90% confidence interval, alpha would be 0.10. So this is usually 1 minus 0.90. So if I say 80% confidence interval, alpha would be 0.20. So in this lecture, mostly we kind of wanted to determine between what range 90% of the people will lie, or what range 99% of the people will lie. So for example, we discussed this in our class that this is population, and suppose I wanted to know the weight of people in Killeen. So it's difficult to know because the population is always changing. So what I do is I take a sample, maybe 100 people in Killeen, and then determine what is their average weight. Suppose the average weight is 160 pounds, then I kind of make an inference about the population and say that the population weight would be 160. However, this is a point estimate, so this is just we are giving a point and we are not confident whether the population, the average population of weight of Killeen, the average weight of people in Killeen is 160 pounds. So what do we do is to gain confidence, we kind of create a range. So we are saying between what range of values, lower value and the highest value, 90% of the people will lie. So that is usually given by confidence interval. So at this time we kind of I will use confidence interval for the population mean, mu. So this is mu is population mean. So the formula for this is given by x bar plus or minus z alpha over 2 sigma by root n. So one of the things you have to know in this is your population standard deviation. This is standard deviation of population is known. This is very important. So when you solve problems, they will say the population standard deviation is known, then you are using z-stat. So that's one thing. And the second assumption is n is greater than or equal to 30, then you will be using z-stat. So the main idea here is to calculate confidence interval. If sigma is known, that is population standard deviation is known, and n is greater than or equal to 30, you are going to use z stat. So this is one of the important thing you need to know in solving these problems. So again, here if you see x bar means this is sample mean, z alpha over 2, so this part is called critical value, and then this whole part is called margin of error. So that's the important, this equation is very important for us. So one of the things is what is alpha actually. So if we wanted to talk about alpha, we will kind of let's okay, so the main idea about alpha, this is, so when we say 90% confidence interval in our normal distribution, if you see our normal distribution from certain point to certain point, so this is minus z and this is plus z, so this entire region, this is 1 minus alpha, so this is 90%. So if you consider these parts, this and this, both of them together is alpha, so that means this will be alpha over 2, this will be alpha over 2. So when we are doing z alpha over 2 in this part, what we are trying to say is this z alpha over 2. So in fact whatever z value you will get, that is z alpha over 2 and z alpha over 2. So here you have negative, here you have positive, so that is taken care by this positive and negative. So that's how you will kind of calculate z alpha over 2. So let's calculate z value for 80% confidence interval. So when I'm saying 85%, that means this from here to here minus z to plus z, this is 0.80, and then this is 0.10 and this would be 0.10. So these two together, so this is alpha over 2, which is, and this is alpha over 2. So I have a probability of 0.10 on the left side, so I just go to my z table. So I will go to mm, the course, and then go to modules in Canvas, and then go to module 0, do calculation aids, and then download statistical tables. So once I go to statistical tables, I go to, so now I have a different spreadsheets. I need to go to Z table. So this is Z. I'll do enable editing. So this, I'm going to Z table. This is the Z table, and we are looking for a we have a probability of 0.10. So I will go and look for 0.10 in our Z table. So these are, so I'm going for 0.10. So 0.10. So 0.10 is somewhere here, this one or this one. So we can select one of those Z values. So the Z will be negative 1.28. So if I consider, or 29, whichever one you want to select, so negative 1.28. So that is Z value here will be negative 1.28 and Z value here will be positive 1.28. So that's how you calculate. We can do one more problem on this and see whether we are able to solve the problem for Z value. So if I say 90% confidence interval, what is the Z value? So again I do normal distribution curve and then look for negative Z here and positive Z here, and then this is 0.90. So this plus this should be 0.10. So this will be half of 0.10, that is 0.05, and this will be 0.05. So if this is 0.05, the Z value here, we just go to the Z table and look for 0.05. So 0.05 would be somewhere, so this is 0.05, almost nearer value. We are looking for nearest value. So this would be negative 1.64 or 1.65. So we will use 1.64 for our case. So this is negative 1.64 and this is positive 1.64. So that's how you will be calculating, and these are called critical values. This negative 1.64 and positive 1.64 is called critical value. Now at this time we try to learn about z value. Now let's go and look at the like how to calculate confidence interval. And see whether we can calculate confidence interval. So we have I will give you an example. We have a thrash manufacturing company. So this company make thrash bags. So this company makes thrash bags. And then the manager claims, manager of this company kind of claims that the thrash bag breaking strength is 50 pounds. So this is the breaking strength of the bag. Of this thrash bag. So what we are trying to do is we wanted to verify whether the company's thrash bags really stand for 50 pounds. So what we do is we take a sample. So again, this is all given. So these will be given. So the samples we take is 40 thrash bags. So we go and survey the company and take 40 thrash bags. And suppose the average of this thrash bags is 50.575. So that means the average breaking strength. So the average, we kind of all these 40 bags is 50.575 pounds, and your standard deviation, this is standard deviation sigma. Standard, sometimes they will say variance is known, both are same. Standard deviation or variance. So these are is known. So that means population standard deviation is known, and that is equivalent to 1.65, and they wanted us to calculate 95% confidence interval. So again, the formula for confidence interval is x bar minus plus or minus, you can use minus or plus. So maybe for our convenience we will kind of use maybe x bar minus plus z alpha over 2 sigma over root n. So that's our formula. So we know x bar is 50.575. Again, this whole part will be given in the problem. And then sigma is known, this is 1.65, n is 40. So now we wanted to calculate z alpha over 2. So as you know, as we discussed, when we draw a normal distribution curve, they gave us confidence interval to calculate this z alpha over 2. So this is negative z, and this will be alpha over 2. This is positive z alpha over 2, and then this whole area is 95%, so that is 0.95. So this plus this together should be equivalent to 0.05. So this part would be 0.025 and this part would be 0.025. So now again, because we have this probability, we can calculate these values. So negative z alpha over 2, so alpha over 2 is, so in this case alpha over 2 is 0.025. So I will go to z table and look for 0.025. So 0.025 is this value, so this will be negative 1.96. So negative 1.96 would be our z value. So this will be negative 1.96 and this will be positive 1.96. So now we will substitute those values. So this z alpha is 1.96 because negative and positive will be taken care of by this symbol. So the first lower limit is x bar minus z alpha over 2 sigma by root n. So this will be x bar is 50.575 minus 1.96 multiplied by sigma is 1.65 divided by square root of 40. So if you calculate this, you are going to get 50.064 and then upper limit is x bar plus z alpha over 2 sigma by root n. So this is 50.575 plus 1.96 multiplied by 1.65 divided by square root of 40. That's going to give us 51.086. So this means our range would be 95% confidence interval range for mu will be 50.064 and 51.086. So the manager claimed that the trash bag will last 50 pounds. The claim is wrong because it's giving more. So the thing is, if we see the curve, our range is 50.064, 95% confidence interval range, and 51.086. The manager is claiming it's somewhere around 50. So the manager is underestimating the trash bag. So that's how it can be interpreted. So if the manager says at least 50, then the manager's claim is good. Here the manager claims exactly 50. So he's kind of saying it's exactly 50. So the claim is wrong because it's kind of overperform. The trash bag is better than what manager is claiming. So that is mostly uh, confidence interval with known variance or standard deviation, and usually this is known. N will be always greater than n will be always greater than or equal to 30. So let's solve this problem using calculation aids and see whether we can solve this problem. So here we have again the given is n is equal to 40, x bar is let me check, 50.575, sigma is given as sigma is 1.65, and then 95% confidence interval. So to solve this problem, we kind of go to our canvas and look for chapter 9 calculation aids. So you can download that copy of chapter 9. So that is this part. So we have different spreadsheets: confidence interval, mean, known variance, confidence interval, mean, unknown variance. So currently we are dealing with known variance. So the first one is known variance and or standard deviation, and n is greater than 30. So we will kind of use the first spreadsheet. So we go to this one and put in values population standard deviation. We go here and look for what is population standard deviation, which is 1.65. So I will type in 1.65 here, 1.65. X bar is let me go and see what is X bar. X bar is 50.575. So I will go to this and calculate. So this is 50.575. Alpha is, so we are looking for 95% confidence, so alpha will be, so 95% confidence interval, alpha will be 0.05. So that is usually given by 1 minus 0.95, that's 0.05. So we go and check alpha, which is 0.05, and the sample size given is I think it's 40. So I'll go here and put 40. And hit enter. You'll get 50.063 and 51. So this is our lower bound, and this is our upper bound which we got, and the critical value is 1.96. They got exact value, which is 1.95, and the margin of error is 0.511. So this is how you are going to solve a problem on uh, mm, confidence interval. So let's try and see whether we can solve a Hawk's problem on this. So here is a marketing research company, and they take a sample of 100 males over age 22, and the mean milk consumption was 3.6. Assume that the population standard deviation is 0.7. Construct a 80% confidence interval. So the first thing you need to note down here is the population standard deviation is known. So they gave it in the question, and then the sample size is 100, which is clearly greater than 30. So let's note down the important parameters in this problem. So let me see. So n is 100, x bar is, so x bar in this problem is the mean milk consumption is 3.6, so that is x bar, and then the standard deviation is known, and that is equivalent to 0.7. So that's 0.7, and when we have a confidence interval of 80%, I think. Let me check. 80% confidence interval. So if you see, this is n is 100, that's clearly greater than, n is greater than 30, and sigma is known. Usually these two go together. So if you can identify sigma is known or n is greater than 30, you just use z-score, so known variance. So we will go to our again calculation aids, and let's do the calculations. So this is population standard deviation. They gave us how much? 0.7. So I go here and put 0.7 here. So that is 0.7. Let me delete those. 0.7. And then x bar is 3.6. X bar is 3.6. So this is 3.6, and then we have 80% confidence interval. So alpha would be, again, alpha is 1 minus 0.80, that is 0.20. So alpha would be 0.20. Again, I have to delete those. 0.20, and then the sample size is I think it's 100. Let me cross check. It's 100. So the sample size is I have to delete this and type in 100 and hit enter. So this is the lower bound would be 3.51 and the upper bound, so that's the lower bound, and the upper bound is 3.68 or 689, so that's 3.69. So we can go here. This is I think it's 3.51. This is let me cross check. 3.51 and 3.69. So this is 3.69. Submit. Yeah, so that's how you solve these problems. This concludes my lecture on confidence interval with known variance or standard deviation and the sample size greater than or equal to 30. Thank you.